Laws of binary operation. There are three basic laws of binary operation, and they are the commutative binary operation, the associative binary operation, and the distributive binary operation. The commutative binary operation. A binary operation style on a set K is said to be commutative if for all A and B, which is an element of K, A operation B is equals to B operation A. Now, when this condition is true, then that operation is said to be binary.
Commutative.
Now, let's consider an example. Example 1. Now, show whether or not the operation defined by the relation below is commutative. Now, this is the relation. P operation Q is equals to the absolute value of the difference between P and Q all over the product of P and Q. Now we're to show whether this relation is commutative. Now for us to do this, we need to choose a random value for P and Q. Let's choose these values from the integers. Now pick any number from integer for P. Now let P be equals to 2. Now let's pick another number from the integers for Q, and Q be equals to -1. Now we are going to solve for P operation Q, we also solve for Q operation P. And if they are equal, then it is commutative. So start it up, we'll solve first for P operation Q. P operation Q. Now, using the formula above, is equals to the absolute value of the difference of P and Q all over the product of P and Q. Now, P is 2 and Q is 1, so therefore 2 operation -1, Q is -1, is equals to the absolute value of 2 minus bracket -1 all over 2 times -1. Now this will give us what? The absolute value of 3 all over -2, because 2 minus -1 is 3. Then the absolute value of 3, of course, is 3 all over -2, and this is the same thing as -3 over 2. So hence we have that P operation Q is equals to -3 over 2. Now we're going to solve for Q operation P, and if Q operation P is the same as P operation Q, then it is commutative. And let's proceed. Let's solve for Q operation P. Now, using the same relation, Q operation P will be equals to the absolute value of the difference between Q and P over Q times P. Now, Q is -1 and P is 2. So we have -1 minus 2 all over -1 times 2. And this gives us the absolute value of -3 and over -2. Now the absolute value of -3 is 3 over -2, and this is -3 over 2. Hence, we have that Q operation P is equals to -3 over 2. So since P operation Q is -3 over 2 and Q operation P is -3 over 2, hence P operation Q is the same as Q operation P. Hence the relation is commutative, because P operation Q is the same as Q operation P. So when this is true from any relation, that relation is said to be commutative. Now let's proceed to solve another example. Example 2. Now in example 2, we're going to show whether or not the operation defined by the relation below is commutative. Relation is A operation B is equals to the maximum of A and B minus 1. Now this is the relation. A operation B is equal to the maximum of A and B minus 1. So the same way we solved for example, we'll solve this example likewise. We're going to choose a random value for A and B to see whether or not it is commutative. Now let's choose a random number for A and a random number for B. Let A be 4 and B be 7. So A is 4 and B is 7. Hence, let's proceed. We'll solve for A operation B, we'll also solve for B operation A. If they are the same, it's commutative, but if they are not the same, then it is not commutative. So for A operation B, which is equals to the maximum of A into B minus 1, then for operation 7 will be the maximum of 4 into 7 minus 1. So this will give us the maximum of 4 and 6. So between 4 and 6, which A is the maximum? Which is the highest number? The higher number is 6. So A operation B is equals to 6. So likewise, let's solve for B operation A. Now B operation A using the formula above will become the maximum of B into A minus 1. Hence, using the same value for A and B, B is 7 and A is 4. This will be the maximum of 7 into 4 minus 1, which is the maximum of 7 into 3, and the maximum of 7 and 3 is 7. So hence, B operation A is 7. So what will be our conclusion? In conclusion, since A operation B is equals to 6 and B operation A is equals to 7, then A operation B is not equal to B operation A. Thus, the relation is not commutative. The relation is not commutative. So, when A operation B is the same as B operation A, then it is commutative. But when B operation A is not the same as A operation B, it is not commutative. If you want to learn more about commutative binary operation, just message me directly on WhatsApp. Otherwise, subscribe to my channel, like and share this video. I will see you in my next video.